Will a tipping point, a new tipping point, be reached for the Antarctic ice sheet? Well, a new tipping point has been discovered beneath the Antarctic ice sheet. Hello friends, Jim here. This is a report that has been published on phys.org by the British Antarctic Survey, or BAS. A new and worrying way that large ice sheets can melt has been characterized by scientists for the first time. Research is focused on how relatively warm seawater can lap at the underside of ground-based ice, which can accelerate the movement of the ice into the ocean. This process is currently not included in models that predict sea level rise, so the new results could offer a more accurate picture of how the world will change with global warming and how much coastal areas will need to adapt. Right. So the BAS did this research. They published their findings in the journal Nature Geoscience. We have identified the possibility of a new tipping point in Antarctic ice sheet melting, says Alex Bradley, an ice dynamics researcher at BAS and the lead author of this paper. This means our projections of sea level rise might be significant underestimates. Like, we've never heard that before, underestimating no matter what it pertains to. The research focused on a region beneath an ice sheet called the grounding zone, which is where the ground-based ice meets the sea. Over time, such land-based ice moves into the surrounding ocean and eventually melts. A process that takes place around the coast of Antarctica and Greenland is a major contributor to sea level rise. The new study models how seawater can seep between the land and the ice sheet that rests on it, and how this affects localized melting of the ice, lubricating the bed, and influencing the speed at which it could slide towards the sea, generally accelerates. And it looks at how this process accelerates with warming water. Ice sheets are very sensitive to melting in their grounding zones. We find that grounding zone melting displays a tipping point-like behavior where a very small change in ocean temperature can cause a very large increase in grounding zone melting, which would lead to a very big change in flow of the ice above it, says Bradley. This happens because warm water melting in the grounding zone of the ice sheet opens new cavities that allow further ingress of warm water, which causes more melting and bigger cavities, etc. In other words, a positive feedback loop gets set up. The tipping point comes because a small increase in the water temperature can have a very big impact on the amount of melting. Ice melt in this way, which is currently not accounted for in the models used by the IPCC and others, could explain why ice sheets in Antarctica and Greenland seem to be shrinking faster than expected. So, including the results of this new work into such models would give better, more reliable estimates. This is missing physics, which isn't in our ice sheet models. They don't have the ability to simulate melting beneath grounded ice, which we think is happening. We're working on putting that into the models now. Well, of course. But those of you who follow me for some time are probably not surprised by this, because you know how often I have discussed the role of ocean heat content and what it does to ice, be it sea ice, cantilevered ice, and I've mentioned what's happened before at the grounding line. So, to be honest, this does not surprise me. I've been talking about it. But still, the important point is that need to include this in the models, and they're saying, hey, we need to include this in the models. So yeah, get this into the models. Bottom line, Antarctic ice is melting, and melting much faster, which means the sea level rise will be much faster. And then couple that with what's going on with Greenland. Sea levels rise are going to continue to increase. In fact, the increase, the fit curve to the rate of increase is a polynomial one. It's a quadratic, the second degree, meaning it ain't linear. Not exactly exponential, but it ain't linear. And it's accelerating. So, there you have it. Talk soon.